I think we just need to mute everyone. Just give
Sorry,
us a moment.
it's not supposed to
Okay.
be.
Welcome everyone to the IBC training. Today our focus will be on Atess. So just for you to note, you won't be able to unmute yourself, but what we will do is if you do have any questions, please drop them on the meeting chat and then we will answer to all your questions. So if you do have any questions throughout the training, just drop your questions on the meeting chat and then we'll try to respond to all your questions. If we fail to respond to your questions through the duration of the training, we will then try to get back to you with answers for that. So today I have Tatenda with me from Atess, who will be presenting the training. Tatenda, welcome.
Thank you. My name is Tatenda. I'm from Atess Technical Support Engineer. Thank you.
Thank you. Welcome to Tender. So I'll start off with a presentation just to show you who we are and our offerings. So I'll just start with that and then I'll just give Tatenda then the opportunity to start with the training. So as IBC, we do have a few offerings. So on our modules and mounting offerings, we do have our own IBC modules with our own mounting structure. One of our famous mounting structures is the Aerofix for your flat roofs. So if you haven't seen that before or don't know about it, just feel free to then just talk to your sales manager and then we'll just then work on a presentation for you to see our offerings. So we do have also Longi, Jollywood, and Canadian on our module side. So we do offer that. So if you have any inquiries, you can feel free to contact your sales manager. On the inverter side, we offer our premium products such as SMA, Fronius, Victron, Goodwe, Atess, and SunGrow. So this is applicable for your residential and also your commercial to utility scale. Now, when you look at your storage systems, we do have SolarMD, which is a local battery manufacturer situated in Cape Town. We also offer from residential to commercial side. SolarMD is one of our very highly esteemed batteries, which was one in the top 50, if I'm not mistaken, on the fast growing companies in Africa. And then we do have BYD, which is also one of our favorite batteries worldwide. Yeah, if you do have any inquiries on our products, feel free to contact your sales manager and they'll get back to you on that. So on our team, we do have in the management department, we do have Daniel and Helga. Daniel Heisler is the managing director, and Helga Frank is the head of finance and operations. In the marketing team, we have the one and only Zane and Carmen, who are responsible for all our trainings. Thank you guys once again. Very fantastic job there. And then on our supply chain and sales administration, we do have Shemaine, Kim, Govender, and Tanya, who are responsible for the operations and administrations of IBC. And then on the accounting side, we do have Hamu, who makes sure that we do not finish our clients' money or whatsoever. But yeah, such a great, fantastic team. And now the most important part will be this is our sales managers and also our technical department. So if you do not know who your sales manager is, this is a very important. You just need to just listen carefully. So Leonardus and Jason Campbell are responsible for the sales in inland. So they are mainly focused in Joburg. But if you are situated in the inland, Leo and Jason will be your main contact. So if you don't have their contact details, just drop in your email and then they will then get back to you. In the coastal area, that would be David and Ridar, along with Carl. So if you do have any need for any products and you're situated in the coastal area, please then contact these three people. So they are based in Cape Town. On the technical division, in the inlands, we do have Vessel, who is mostly responsible for the technical inquiries that side in the Joburg area and surrounding areas. And then in Cape Town or the coastal area, you will have myself, Honse, and Jama responsible for the coastal area. So if you do have any technical inquiries, need technical assistance on the products that we offer, then you can feel free to contact any one of us. Now, the sales managers, as I mentioned, all the 5 sales managers there, they do offer online portal training every second week of the month. So if you do need some technical guidance or guidance in maneuvering around our online portal, please then contact your sales managers, and then they will just offer you like a quick training, so you are able to find everything that you need, such as your documentation, like your tax invoice, your pro forma, everything is available. Our online shop is user friendly. It shouldn't be an issue for you to get the hang of it. So feel free to then contact your sales manager, and then they will assist you in that. Now we do have now webinar recordings available as of last month. So what we do now is all our trainings are recorded and then uploaded onto our online shop. So Zane will then just drop a link during the course of the training so that you can find all our webinar recordings. Now we do have like a very, very huge special this month. This is our IBC solar sales deal, where if you then purchase anything above 500,000 Rand excluding VAT, we will then offer you a free delivery. Yes, I said it, free delivery for everyone throughout the month of May if you purchase anything above 500,000 Rand excluding VAT. So make use of this deal, and yeah, just contact your sales managers to make sure that everything runs smoothly for you. That's what they are there for. Now we also have another free special same month, where if you purchase our mounting system for corrugated roofs, we will then just give you 100 free corrugated metal sheets. 100 free corrugated metal sheets. So make use of this deal. And yeah, if you do have maybe a system and you need guidance in terms of what mounting structure you need to choose for your corrugated roofs, our technical department can then assist you in that and also make sure that you get your 100 free corrugated metal sheet adapters. Now that is all from myself. So what I'll do now is I'll just hand over to Tatenda, who will then start with the technical training. So as I said, if you do have any questions, drop your questions on the chat, and then we'll make sure that all your questions get answered. And if we are unable to, we'll then reach out to you. So you'll just have to leave your email, and then we'll make sure that everything gets answered. So Tatenda, I think without further ado, I'll just give you this opportunity to then start with the training. And yeah, we hope to learn a lot from you today. Welcome, Tatenda.
Okay, thank you very much. Can everyone hear me? So, okay, let me share my screen. Are you guys able to see my screen?
Oh, not yet. Maybe you can just try again now.
How about now?
Okay, there we go. Perfect.
Okay, so today I will start with the HPS system training. I will look into the HPS system introduction, the installation, the commissioning, a bit of troubleshooting, and the tools that you need when you are troubleshooting, installing the system. So our HPS, it's a hybrid inverter, which encompasses all battery load, grid, solar connection, all supported in one device. So inside this HPS, we have our MPPT inside, the converter for DC to AC, DC to DC inside. So inside the HPS, you can connect your grid. So we have one AC input. So in the event that you have generator and grid at the same time, you say that you need an ATS from Atess, or if you have an already existing ATS on site, you can also make use of it, provided it is a dry conduct that tells us is the grid running or is the generator running. So the HPS is a programmable working mode that is peak shaving, backup. You can use it load first. So I will show you the working modes that we have on the next slides. And then we also have the touch screen where you change your parameters. It allows a seamless transfer, 20 milliseconds. But I'll explain for you to get those 20 milliseconds seamless transfer, what you need to do on your design when you're designing your system. And then it also has the dry contact output, supports remote control of your generator. Okay. HPS system, the HPS mode, we have on-grid mode, off-grid mode, and single PV mode. You can also use it EMS mode. So in on-grid mode, you can select load first, battery first, economic mode, and time scheduling. So on time scheduling, let's say between 5 maybe to 9 p.m., the tariffs are very high. You can set your system not to use any grid on this time so that you can save on your tokens. And then economic mode is the same thing. Economic mode, during your peak hours, you don't use grid, and then you can charge your battery maybe in the evening when you are not in peak mode. And then battery first, this is more like a backup. Your battery first, your battery will stay charged. And then in the event of a load shedding, then you can make use of your battery, like the storage. And then load first. In load first, your PV will supply the load first, and then the remainder is used to charge the battery. In off-grid mode, when PV is greater than load, when PV is greater than load, PV gives priority to the load. When PV is less than the load, battery will discharge. That is in off-grid mode. But when this happens in on-grid mode, then your grid will help to charge the battery. That is, we should set it to battery first. And then if the battery is insufficient, switch to the single PV mode or start the oil engine. So when your battery is insufficient in off-grid mode, then you can set your inverter battery, let's say at 30%, 25%, charge the battery maybe to 50%, and then it will stop. That will be done automatically. And then EMS mode, this one, when you have a control system that you want to use, you can control the charging and discharging of your equipment through remote EMS. This is your energy management system. I've seen people using Elam, Data Guru, SolarMD also has a system that they use to remote charge and discharge your system, or control your system, even monitoring your system. Okay. In on-grid mode, we have load first, battery first, economic mode. So PV sufficient, PV supply the load, and PV charge the battery. When it's insufficient, then you discharge your battery. If the battery is insufficient, you can start your generator. And then we have battery first mode. So your battery will always be charged. So it will be charged with PV. If PV is not sufficient, it will be charged with grid. So your battery will always be at 100% if you set it to maximum charge SOC to 100%. And then we have economic mode. I don't know if you can see clearly. I'm trying to zoom. Economic mode, we have value price, fair price, and peak price. So in peak price, this one is usually the most important, where your prices are very high. Now you're just using your battery instead of taking power from grid. Okay, so our HPS, we have a range from HPS 30, 50, 100, 120, and 150. These HPS systems can be paralleled up to 4 units. So the maximum you can get from an HPS is 600 kilowatt system. So our HPS is divided into two parts, mainly two parts. We have the power side and then the control side. So on the power side, I don't know if you can see. So we have the PV combiner, combine all your PV and then you connect it on the PV input. We have the battery input and then the load. As I said, we only have one AC input. So our AC input, one port. So if you have generator and grid, you can make use of the ATS. So grid and generator into the ATS, the output of this ATS, you connect it to your AC input. And then on the battery, mainly usual people right now are using batteries with BMS. So your BMS is connected to CAN A. So in this diagram, I'll share these slides with IBC, and then they'll send you. So the solid lines, these indicate power cables, and then the broken lines are communication. So when you're connecting your PV battery load, these are the size of the cables we recommend. So for PV, you combine your PV inside your combiner box, and then you take 50 square millimeter. If it's HPS 50, if it's HPS 120, 120 square millimeter, that is 100 on the positive, 100 on the negative. And then the only difference here is usually on the N wire, where here on HPS 150, you use a 150 square millimeter cable. So in the event that you have two HPS systems or three HPS systems, your battery cable length should be of the same length. Your grid cable, your AC input cable should be the same length from the point where you are connecting, and then your load to your combiner where you are combining your load, the length from the HPS should be of the same length. Okay, this is how the internal components of our HPS look like. So point one, that's your PV breaker. That's where you connect your PV cables, the battery. And then we have AC input. So AC input, if it's an HPS 100, you can send 100 times two times the size of your HPS capacity. So if it's HPS 50, you can get 100 kilowatt from HPS 50 on the AC input that's used to charge the battery. The other one pass through to your load. And then 6, that's our fan power supply. So on top of all the HPS, there are about 7 fans that are used to cool the system. So this is the power supply. So if your fan is not switching on, maybe just need to check here to see if all the connections are right. And then we also have our SPDs. In the event of a lightning, you see your SPDs. So we have a DC and then the AC one. So if your SPD is damaged, your system will not run. You just need to replace the SPD. Okay, so inside the HPS, we have 3 boards. boards, the main ones. So we have the control board, we have the relay board, and the sampling board. So the control board, this is where you load your program, where you connect your RS-485 connections, CAN A, CAN B. So on point 1, this is our RS-485 port where you connect your analog, your Shine Master, all the monitoring you connect here to get the monitoring. And then number 2 is our CAN A interface, where you connect your battery. CAN A interface is dedicated to BMS only. Nothing else should be connected here except for your BMS. And then number 3, we have CAN B interface. So if you have an ATS, you connect the ATS communication line to CAN B. And then we have CN18 and CN14, that is number 4 and 5. If you have 2 HPS in one side, you need to parallel them through these connections. So if on the master you connect to number 4, that's your CN18.
Tatenda, I'm not sure if there's some network issues, but we cannot hear you at the moment. Apologies for that. We seem to have a bit of technical difficulties. We'll just fix that shortly.
Tadenda, okay. Okay, it looks like we have some technical difficulties. We're just trying to get Atenda back in the call. Let's just give him a minute or two.
So apologies for that. We do have some technical difficulties, but if you do have any questions in regards to Atess as a product, let's see, you can just drop your questions on the meeting chat, and we do have one of our in-house specialists, Carl Swanepoel, who might also be able to assist us with any technical questions on that.
Welcome back to Tenda.
Sorry, thank you.
There you are.
At which point did you?
Tadenda, we just lost
Tatenda?
your screen
Yes,
again.
hello.
Yeah.
Okay. Yes,
Yeah.
I was saying at which page did you guys lose
Or
me?
you can just go down.
Okay.
Page 9. Yeah.
Okay, page 9. Okay, sorry about that. Okay, so I was explaining on this with the RS-485 interface where you connect your monitoring, and then CAN A, that is number 2. Let me just zoom in so that everyone can see. So this is our RS-485. It's labeled here on the control board, and then we have CAN A. CAN A is dedicated for the BMS only. And then CAN B, if you have your ATS in the system, or if it's on the PCS, you have your bypass, you connect it here. And then number 4 and 5 are used when you are running a parallel system. You just daisy chain your inverters. So if you connect master on number 4, on the slave you connect 5, and then if you have 4 inverters, you just daisy chain them. So if you are using a battery, most local batteries, they are compatible with our system, but we just need to find out if the communication protocol is compatible with our CAN-A. So in the event that you're using Pylon Tech batteries, if you enable your BMS, you set it to 2. So if you're using Pylon Tech or all batteries under Pylon family, you contact one of our support team or the in-house support team. They can help you. It's not difficult. It's just changing the BMS communication enable value. That's the only thing you change. So inside the ATS, the 150. So if you have HPS 50, you need to use ATS 50. If you have HPS 30, ATS 30. But if you have HPS 50 in parallel, you can use ATS 100, and then you just share them. So inside the ATS, we have ATS control board switch. That is number 1. Number 2 is your grid input, generator input, number 3. So the output is number 4. This load is the one that you connect to your AC input. So number 4, you connect it to number 3 here inside your HPS. And then there's something that I skipped here. We have our bypass breaker, that is number 4. So in the event that you want to bypass your system, you can bypass it here with number 4. So you switch off everything and then you switch on MCB number 4 to bypass. If you're doing any maintenance work, you can bypass with bypass number 4. But for you to bypass, you need to make sure that everything else is off, and then you switch on your bypass. So your AC input will just go straight to the bypass and to your load. And then inside the HPS, we have our backboard. This one is the one that powers the ATS. So inside the ATS, there is no power supply there. So you have to power the ATS via the backboard, through the backboard. And then your ATS power should come from this, because if you connect it on your AC input, the moment you lose your AC input, your ATS will go off. So it's best you power it through from the battery. So this one is the ATS control board. So from your CAN-B that is number 2, sorry, CAN-B number 3, you connect it on the ATS control board on CAN-A. So I have some SLD diagrams that I will share with you. So when you're starting your installation, you can just refer to those SLDs that I will share with the team. HPS installation. So after connecting all the lines, you just need to check polarity, the 3-phase sequence. So our HPS, the phase rotation should be clockwise. So your AC input should be clockwise, your generator input should be clockwise. So if the site maybe is running this, the machines are running anti-clockwise, then you just connect the load in the anti-clockwise direction, but everything else you have to connect it to in clockwise direction for it to work. So if you connect your grid in anti-clockwise, your HPS will not accept the. So in this, the problem with wrong phase rotation can lead to damage of the SCR, which are found here. They're used for switching purposes. So sometimes ESCOM guys, they come, they work on the line, they swap the phases, and then you are not on site, and then now the system will sequence fault. So the best thing you can do is you contact your client, they just switch off the AC input breaker before it can damage anything, and then you can correct the phase sequence. So on the screen of our HPS system, this is the screen. So your PV voltage, PV current, you see the values here. So when you're designing your system, your VMP should be at least 100 volts higher than your battery maximum voltage. Please take note of that. For efficient optimum charging of your battery with PV, your VMP should be at least 100 volts higher than your battery max voltage. So any value between 100 to 200, but at the same time, you are not supposed to exceed 800 volts on your VMP. And then our battery input voltage is 352 to 600 volts on a system. So also take note of that when you are purchasing your batteries, and then also the VMP issue. Also note the difference on the VMP and VOC. I've seen some issues on the VMP and VOC where you just use your VOC as VMP, but VOC is different from your VMP. And then here, let me zoom it in. Okay, so on the HPS here, you see the model, it will write HPS 30, HPS 150. So if you switch on the system, after it restarts, if your HPS is HPS 150, it should write 150 here. If you see a different value, then contact technical support. We help you on how to change it. And then the output voltage, you see this is the first, and then the load current, grid current. So when you start up your system using the battery, you configure all the parameters, you run it, your load is off. So your output voltage, if it's saying 380 or 400 volts, 400, 399, you measure on the AC output on top of the breaker, you measure and check if you have the same values here. You can have values, maybe there's an issue with your system, you can have 400, 400, the sampling is wrong, but on the output, you're not getting the 400. So it's always best to measure the voltage before you supply your load. And then when you switch on your load, you can use your clamp meter, you measure the current on the output cable, compare it with these values. And the same thing with the grid. So your PV power, you see it here, the kilowatts, the battery power, output power, load power. So on that screen, this is where you find your on off and then operation data. On operation data, that's where you see your running data. So if your PV current, your output voltage, PV voltage, it just gives you the more information compared to the one that you see on the home page. You can also get your battery information here, the maximum voltage, the battery cell temperatures, and everything. You get it here. So this information, it's the HPS information, then the information that it gets from your BMS. So on the information, so if you click here on the system setup, you get to this page where you have your information page. So this one is it shows you the firmware version, that is the DSP, the software version on the LCD, the hardware version. So in the event that you have two HPS in parallel, or 4 of them, you need to check this DSP version. It should be the same. So in the event that you buy different versions, you have to update the version. So we can help you with that. To conduct technical support, we help you with how you update the firmware versions. Okay, so when you want to set up your system, click settings and then maintenance. The password is 1234. It's here in these notes. You can go through them when you're doing your installation. So on the first page, that's our protect parameters. We had grid max voltage, grid minimum voltage, our frequency. So your grid minimum voltage and max voltage, these are the max and minimum values. You cannot go above this 440. You cannot go below this 340. So you can set any values in between, but it's always best to leave these values like this, unless there is something that you want, specific values that you want. You can set them how you want, but it should be within this range. So our frequency 52 minimum and then 48 minimum. So your frequency should not be above 52 or below 48. So in the event that you're connected to a generator, your generator starts, but the HPS cannot accept the generator, it might give you an error of frequency too high or frequency too low. So what you need to do is maybe tune your generator so that its frequency, when it's on load, it's within these parameters. And then now check time. This is the time taken when you start your system. It will count 60 seconds to start. I've seen some of our clients reducing this value, but according to NRIS standards, they want it to be at least a minute. And then the output limit. So if your HPS 100, your output limit is 100 kilowatt. 105, that means your peak current is 105 kilowatt, but it's always best to set it to 100. And then your output voltage, this is 400. So when you are installing, when you're on the commissioning part now, you just need to verify these values. Are you running 400 or 380? You can change it to 380 or 400 depending on what you are running. And then we have charge current. So our charge current, this is the current that you can charge your battery with. So if your battery is charge current is 200 amps, you can set it to 200 amps, but you should consult the battery manufacturer first. If your battery is at a 1C, a 0.5C, I've seen some batteries written 1C, but they are not 1C. So if you are not sure, it's best you set a half of what is displayed on your battery nameplate if you are not sure. But if you can get with the battery manufacturer, they can assure you this is the maximum that you can charge with. But your maximum charge, your charge current should not exceed what's written on the nameplate of the HPS. Even if you have a big battery bank, but your HPS cannot give you 200 amps, you set it to the maximum of the HPS. You cannot exceed. Okay, now we have grid power. Sorry, I think I skipped something. Okay. We have grid power limit. This is the limit that you want your inverter or your HPS to take from grid. So you can set it to 50 kilowatt, you can set it to 100 kilowatt, depending with how much you can get from your transformer, the client side transformer. So if you cannot get more than 100 kilowatt, but you have an HPS 150, you just set it to 100 kilowatt. And then max SOC, minimum SOC. This is for battery start stop, your generator start stop. So minimum is start, maximum is stop. So these ones, you can set them depending on what you want or what your client want. And then we have cutoff voltage. So when it comes to battery settings, I prefer you get the information from the battery manufacturer. But if you are not sure, you can send us the nameplate of the battery. We can calculate these values for you. So at cutoff voltage, most lithium batteries, the cutoff voltage is 3 volts. So if your system is running off grid and then it gets to 3 volts, one of the cells gets to 3 volts, the HPS will cut the output. You will not get the output. It will just open the output conductor, and then there will be no load. There will be no power on the load side. And then change to offline. This is when you are changing from PV single mode to off-grid mode. So when your battery charges to change to offline. So change to offline for most batteries is around 3.3, 3.4, but each and every battery has got its own value. So if you're not sure, contact us, contact your battery manufacturer. If you cannot get hold of them, contact us, give us your nameplate. We calculate these values for you. So for Atess, the online support is free. You contact any of our engineers. We help you with online commissioning, troubleshooting, and everything. If there is an issue with your site, if it's an inverter problem, an artist problem, we come on site and fix your problem. If your inverter is still under warranty, we provide the spares. In some of the space, we give them to our distributors. So IBC should have a warehouse with space for artist products. You can also get them from our office. And then we have batteries. So if you have 5 batteries in parallel that you've connected to your bus bar and then to the HPS, the number of batteries here, you write 5. Battery cells, most batteries, the nameplate is written number of cells in each battery. So on the battery cells here, you have 5 in parallel and each battery is 160 cells. You just write for 1. So the inverter will know I have 5 batteries with 160 cells each. Battery capacity, you write the AH value, not the kilowatt hour value. So if you have 5 batteries, 100 AH, you just write 100, the kilowatt, the AH value, the MR value for one battery. I have 5 batteries, it's 100 AH each. And then the only difference is here on max current charge and max current discharge. So on this one, if you have 5 batteries charging at 100 amps each, you just write 500 if the discharge is also 500, or just say is half of the maximum, the total charge current of the total batteries. So if 5 times 100, that's 500, and then divided by 2, you can write 250, 250, or if it's 1C, you write 500, 500. But these values should not exceed the charge current that's displayed on the HPS nameplate. So you just verify with the nameplate, it's on the door or on the side, on the left side. You just verify what's your max charge current. And then we have overvolt fault at this value. So if your overvolt value is 3.6, if your battery charge is beyond 3.6, the system will go into fault mode. And then we also have undervolt warning. And then float charging is based on the float charging voltage of the battery. So these values, these battery values, you get them from battery manufacturer or inside the manual of the battery, you can get these values, but some manufacturers don't write this for you. So if you are not sure, contact us, because if you put a wrong value here, your system will not work. And then there's also another issue that I want to. Okay, so we have our cutoff voltage. So most lithium batteries, the cutoff voltage is 3 volts. So you can have a battery bank with 160 cells inside the bank. So if one of the cells is not working properly, there's a bad cell, you might find out, okay, my system is showing 60%, but it trips with battery voltage too low. So you need to then check inside the battery. Is there a cell that's misbehaving? You can check it by going to your data page. Should be the second last page on the data, the operation data page, where you can see the max and the minimum cell voltage. So always check your max and minimum cell voltage because they affect your system operation. So battery settings are critical in the fact that they affect how your system behaves. And on the new firmwares, we now have your cutoff charging power of grid. So in this, if you want to charge with the grid, you can set at what SOC your system should charge with grid. So if you set it to 80%, it will stop charging with grid at 80%. And then we have number 6, which is charge stop SOC. This one, you have to set it to from 95 to 100. For some batteries, it's 100. So if you see doing an installation, commissioning, you run your system and then it stops charging maybe at 50%, you need to check this value. Is it set to 100? So for this client, it was set to 90 and then just stops charging at 90%. Why is my battery not going above 90%? Just verify this value. And then we have generator power limit. So if your generator is a 100 kVA, you say you multiply 100 kVA by 0.8 and then you put it 80. So this is a kilowatt value. Generator power limit 80 kilowatt, or in this case, it's 100 kilowatt. So if you have one generator and 2 HPS in parallel, and your generator is a 100 kVA, you say by 0.8 and then you divide. So each and every inverter will take 50 kilowatt from the generator. So always verify these parameters, because you can run into a problem where your generator trips when it runs, because the HPS will try to take 100 kilowatt from a 100 kVA generator, of which it can only get 80 kilowatt from a 100 kVA generator. So always be mindful of this parameter. And then we have discharge cutoff SOC. So when you're on grid, grid is available, your system is on grid, your system will stop discharging the battery at this percentage, like this SOC percentage, 30%. And they need to start supplying the load with grid. In the event that you lose grid, the HPS will start discharging the battery from 30 till it gets to under voltage value. So for this one, you can set it slightly higher if you're experiencing a lot of load shedding. You can set it slightly higher. And then we also have our grid charging power. This is the power that you want your batteries to charge from grid. So your grid limit could be 100, but you only want to charge with 20 kilowatt from grid. You don't want to charge with a lot of power from grid. You can set this value. You can even set it to 0 if you don't want to charge with grid. So this is the peak values where you set your times. If the peak time is between 9 and 11:30, you set it like this. And then the valley time, this is when you can charge with grid. At this time, you only discharge with the battery. At this time, the flat time, your BMS is just in a waiting mode. It's neither charging or discharging. It's just in waiting mode. And then below our protect parameters, we have the sample parameters, the sample calibration on some HPS versions. So we have island protect level. So this level is from 0 to 9. This is how quickly your system switches, like the SCR, when the voltage of grid is low or is high, or when you connect your generator, when your generator starts. And then we have grid and PV charge together. So you need to enable this one for grid and PV to charge at the same time. And then on number 4, we have BMS communication enable. So if you have a BMS, you have to set it to 1. If you connect your BMS cable on CAN B, you set it to 1, you enable it. If you are using lead acid, then you leave it at 0. Anti-backflow. So if you want to export if you want to export power to the grid, if you have the license to export, then you set it to 0, and then you can also set the amount of power that you want to export using this one, upper limit feed from grid. It has been changed. There was a problem with this English that was written here, but the code has been changed now. It's upper limit to grid. That's feed to grid. So you can set it to 20 kilowatt, and then your system can only feed 20 kilowatt to the grid. And then if you have a generator, DG enable, that's your diesel generator, should be enabled for your SOC max and minimum to take effect. You have to enable this one. For your generator to start automatically, you enable this one. And then in the event that you have a parallel system, you set parallel enable to 1. Number of parallel machines. If you have 2, you set it to 2. If you have 4, you set it to 4. And then we have parallel redundant number. You can set this one to 1. So in the event you have a parallel system, 2 machines, you can set parallel redundant number to 1. So in the event that one machine goes into fault mode, the other machine will take the load, but your load should be lower or equal to the size of your one inverter. So if the load is above, let's say you have 2 HPS 100 in parallel and the load is 110, the whole system will trip. But if the load is 90 kilowatt, 95 kilowatt, one of the inverter will take the load and then parallel address. So the master should have the parallel address 1, the slave 2 should be have 3, and then the last one should take parallel address of 4. So these are the description of the settings that I was talking about. So you can go through these ones when you are doing your commissioning or before you go to site. So this is anti-backflow enable. On some inverters, it's written anti-reflux. So usually we set it to 1, meaning that the function is turned on, the energy will not flow to the grid. So if you set it to 1, there is no export to the grid. If you set it to 0, you can export to grid. So in the event that you have 2 machines in parallel and then you are using our analog to monitor your system, the monitor parallel judgment sign should be set. If you have 2 machines, you just set it to 1, then the analog will monitor all the devices, and on your platform, it will sum, if it's the PV, to sum the PV from inverter 1, inverter 2, inverter 3, and then it will display. If it's 0, it will only display for one inverter. So you have to set it for you to get the totals of your PV and your load. And then we have ATS enable. So if you are running with our ATS, you have to enable this, and then the number of ATS, if there are 2, you set it to 2. If it's 1, you set it to 1. And then in the event that you are using our smart meter where you have critical and non-critical loads, you have to enable your smart meter, and then you put your CT ratio of the meter. You just check the CT ratios, and then that's the value that you put here. So sorry. Okay, so AC overvolt time. So in the event that there is an over voltage on your in your circuit, so this is the time taken by the HPS to react to an AC overvolt issue. So if the sampling through the sampling board, if there is an over voltage, and then this is the time it will take. So this one you can set, excuse me, you can set it to 4. 4 is like the value that comes with the inverter, and then you can set it to 6, but I advise you to leave it at 4. So these are the data pages that I was talking about. I can't zoom clearly, but I don't know if you can see. So your battery voltage, battery current, your PV power, PV current, you can see all the running data via these pages. That's your data pages. This is the operation data pages. So I think we will schedule another training for troubleshooting the system, because I have a file that we created for troubleshooting all the common faults that we have experienced and then what to do. So if you're going to site, if there's an issue, these are the kind of tools that we would prefer you to have when you're going to site. Your claim meter, your meter. We also need an emulator in the event that your control board is locked. This is the cable that we use for updating the firmware. If you are going to a site with a parallel system, the versions are not the same, then you need this cable to update your firmware. This is my last slide when it comes to HPS system.
Tatenda,
Okay,
sorry.
yes.
Are you still going to do the last slide, or you've finished with
I just
the...
wanted to check on the
Okay.
chat if there are any questions.
Yeah, seems like there aren't. But if you do have any questions, please feel free to drop them. I do have a few questions, but let's just wait to see if anybody has questions. And then, yeah, let's take it from there. Just give it a few seconds. Okay, we don't seem to have any questions. So Tatenda, I just wanted to find out from you. I am not very well equipped on the HPS side. So I saw on your first slide in the beginning, there was an energy meter. I'm not sure if you can go back to that slide.
Okay.
I think it's just like the first page of like a small pictorial SLD. Yeah, slide number 3, I think, yeah.
Slide number 3.
Jan Berger, yes, all the slides will be provided. We will provide the slides also with the training for today. So it will be on our upcoming webinars. That's where Zane just posted a link, so you will find all that information up there. So if you want to have a look at all our previous trainings, they'll be available there, and also our future trainings. So I see that, okay, perfect. So I see that with the HPS 100, you have an Atess energy control meter.
Yes.
That's on the grid side.
Yes.
So I
So,
could yeah.
okay, you can finish. Sorry. You can
Yeah.
finish.
So I could basically then have some, non-essential loads, um, and then feed any access back up until the grid point on the energy meter side, and then just feed any access to the non-essential loads. That's
Yes.
possible, right? Okay.
Yes,
Okay.
that's possible. So this is our energy
I
meter
see.
and then the non-critical loads. If you saw that page where I was saying your CT ratios, so these are your CTs, you check the ratio, you have to enable it for this mode to work. It's also another mode that we have.
And then do
Yes.
you have is there any approved energy meters that we could use? The energy meters like your Schneider and your Janitas. Is there like maybe an Atess energy meter that just has to be used to that's compatible with Atess, or is there a list?
Currently we are using the one that's only one so far that's compatible with Atess. I'm sure our sales team, I'll advise them maybe to send you the information and the energy meters. As of now, that's what you are using. Unless if you are using an EMS system, maybe then you can use your own energy meter. And then on the CTs, any CT is compatible with the energy
test.
meter. Yeah. So
As long
what you
as
can
the
get.
secondary ratio is is it 1:5? What's
Yes, yes.
okay, 1:5. Okay.
Oh,
Okay.
oh,
Okay, perfect. Yeah, I think that's just one of the questions I had. What else on? Yeah, and then that's it from my side. Any more
okay.
questions? Let's look at the chat. Hey, we do not seem to have any
Any
questions.
questions? Okay, that's fine.
So the maximum HPS that you can
Yes.
parallel and still continue to have seamless changeover is that 4. I've seen a site there where they had 5 HPSs, and I saw in your recommendation that's 4. I'm not sure if maybe that's something that'll be updated, or is for recommendation, it's still just keeping to 4 HPSs in parallel.
At the moment, keep it to 4 HPS in parallel.
Mm.
The same applies to the PCS. I'll just do a presentation on the PCS after this. So just keep it to 4.
Okay.
Yes.
Perfect. Okay. Thanks.
Okay.
No questions on my side.
All right. Sorry. So I will go through the PCS system. Just a quick one, David. How many of your clients have done more than two HPS installations or PCS or artist, any artist product, 2 sites and above?
I think we might have one client who did that. Just need to somewhere there in Joburg side.
Oh, okay, that's
Yeah.
fine. Is he with us today?
Unfortunately not, no.
Okay, that's fine. No, because I just wanted to know what I should be.
But I think what I can do is maybe we can just have a chat with them later on.
Okay.
I'll just organize that, yeah.
Okay, that's fine. Okay. When it comes to PCS, so our PCS range, this is the basic composition of a PCS system. So an HPS is made up of these 3 units, that PBD, PCS, bypass. So it's a combination of these. But now we are looking into large scale. So for our PCS, we have PCS 100, 120, and we recently launched our PCS 1 megawatt. So PCS 1 megawatt, you can parallel up to 4 to get 4 megawatts, and then if you have 500, you can parallel up to 4 to get 2 megawatts. So if you have a 500 kilowatt system, you just need one piece of PCS 500. We also have PCS 250, 500, 630, and 1000. And then on the bypass, we have also each and every PCS has got its bypass. But if you have 2 PCS 500, you can also use bypass 1000. But your bypass size should be bigger or equal to the PCS size. It cannot be lower. But you can have a PCS 250 and then you put your bypass 1000. So maybe you are doing a system, you want to do it in stages. You can have a bypass 1000, you have your PCS 250 or 500, and then on this second stage, when you want to increase your size, you can add another PCS, but only have one bypass. So I'll start with this PBD 250. So PBD this is our MPPT. So it's a 250 kilowatt MPPT with 5 modules inside. So each module is 50 kilowatt. So now on this one, you can have like different orientations. So each MPPT module should be connected to the same orientation. So there are 5 inputs, 5 PV inputs inside the PBD. So this is just a basic DC to DC booster circuit. So this is our electrical circuit for the PBD, that is PV1 to PV5. Each and every input is an SPD, and then the breakers, you do DC to DC converter, and then the output on the PBD DC is connected to your battery and then PCS. So they are just on the same point. let me just try to zoom in. So at the back of our PBD, these are our modules. So this is module number 1, the 5 modules. These are MPPTs, 50 kilowatt each. And then, sorry. So this is the sample system. So this is our PBD, your PCS, your bypass. So on the PBD, there is no limit of number of PBDs that you can have on your system. You can have as many as you want. I think the only thing that can limit you the number of PBDs is the size of your battery and your PV size. So on the PCS, I said 4. On the bypass, so here you can have your bypass 500, you can have your bypass 1000, doesn't matter. But here you have your PCS 250, and then your 1000 here, you can have 4 of these and then connected to one bypass 1000, or 2 of these ones connected to bypass 500. So the first page, the front page of your PBD, what you see is your PV voltage, your current, and then now PV1. So the input 1 connected to the first MPPT, it will show you the kilowatts that is producing here. And then output, the total PV power, this is the summation of these 5, sorry. And then charge demand. So your PCS is connected to the PBD, and then it will send information to the PBD of the charge demand, charge that's required to charge your batteries. This will be coming from a BMS. But so your charge demand can be 50 kilowatt, 100 kilowatt, depending with what SOC your battery is on. And if the battery is full, the charge demand will be 0 here. And then the BMS state, so your battery can show you that is it charging, discharging, or it's just waiting. So some batteries might not give us the BMS state to just say waiting, or to show that it's on standby, but your battery will be charging and discharging. So this is our operation data. So you are here on the home page. If you click operation data, then you see these running information. So PV1 voltage, PV1 current. So in the case of PBD, the PBD is a boost circuit. So your VMP should be lower than your battery maximum voltage. So I usually recommend the VMP of around close to 600 volts. It's different with HPS. Take note of that. The HPS uses a buck circuit. So your VMP on the HPS should be at least 100 volts higher than your battery maximum voltage for optimum charging. But in this case, it's different. So on the second page of our data, you see your output power, your ambient temperature module. So if you are designing your system in a container, it's best you separate the battery and the inverters. So these inverters, you can put your extraction fans and everything. And then on the battery side, then you can put your aircon. So the reason why we don't advise clients to put aircon on the HPS PCS side is because we don't want moisture to start forming inside these on the control boards, because it will damage the control board. So if you put just extraction fans, ducts, you design your duct, extraction fan, it will be good enough for the cooling of the system. But on the battery now, you can put your AC. Okay, the same way you start your system. So if you're starting your system, you put the knob to on position, and then you come here on off, then you just click the on button maybe once or twice, and then your system should start running. How you see your system is now running. You check operation state. So here to be written 60 seconds that you check in time is to start counting down to 0, and then at 0 your system will start running. So you see your PV starting to ramp up from 0 to 50 depending with the PV input that you gave to your PBD. And then this is the same as the HPS. Our firmwares are pretty much the same. So on the information page, you check your LCD, your DSP version. So if you have two PBDs in parallel, you check they should be on the same version. And then we have our own PPT voltages. This is just the values that are being sampled on your system. And then the main thing that you should worry of on the PBD, sorry, is your battery settings. You just, sorry, your battery settings here. So most of the settings will come pre set, and then this is where you should put your main focus on the batteries. So if you have 5 batteries in parallel, you set your number to 5 battery cells. If it's 160, 120, you set to 120 for each battery, and then float charge volt. So if your PCS is a float charge of 3.5, so this one can have a float charge of 0.3, 30 millivolts, 50 millivolts higher. I've seen that 50 millivolts higher work best. So if you have 3.5 float charge on the PCS, on the PBD it should be 3.5 plus 0.05. That's your 50 millivolts. So it should be 3.55 for efficient charging of your system. And then this is the communication diagram for the PBD. So you have one PCS, one PBD, one battery. So can B PBD is wired to can B PCS, and then can A from the battery goes here, and then you have to parallel this one with this one, because PBD also needs BMS information. So you need to parallel this one. If you are not sure, just contact one of our technical support guys, and then they will help you with the wiring. But the diagrams that I'm going to, the SLDs that I'm going to share, they have all the diagrams. But if you're not sure, you can get in touch with one of us, and then we'll help you. So this is the full communication diagram for our PBDs. So in this case, we have 4 PBDs. If you check here, the red lines, the red dotted lines, this is our can A, and then we also have can B that's being paralleled. So our can A is coming from this PCS. So from the battery, you go to PCS 1, it's paralleled to PCS 2, and then from PCS 2, we parallel with PBD number 1 in today's chain, or the can A ports. And then the same for the RS485 interface. We just wire the same way with the can A, but on RS485 we don't have the battery, we have our analog, that is our monitoring system. So these are the PV PV1, PV2, PV3, 4, and 5. These are our inputs for your PV. So you combine your PV and then you just have positive and negative one cable going to your PV inputs. And then here, just below the PV input breakers, we have this 220-volt breaker. This is for your fan. So inside this PBD or HPS, you'll find that there's a temperature sensor. So it senses temperature. We have temperature sensor, the ambient, the converter temperature sensors, and transformer temperature sensors and everything. So when the temperatures goes up, you will hear the fans running. So if you're starting up your system and then you don't hear any fan running, if you put on your PV and it starts running and then you don't hear any fan running, then you contact one of us, we help you. But these ones, they run based on the temperature that's being recorded or that's being sampled. So this is the basic SL. Oh, sorry. So now over to the PCS. So what I said about the PPDs, the charge controller, 5 MPPTs each. You can parallel as many as you want. And then the PCS. Now the PCS is the converter. This changes DC to AC and then AC to DC. So this is the basic electrical diagram for our PCS. So we have DC input, the inverter circuit, the IGBTs and everything in the AC filter, transformer, and then the AC conductor. So for PCS 250, the transformer, we have the transformer inside, and then on PCS 500, the transformer is very big. We also have the transformer as a standalone device. So we also have an isolation transformer. I will show you on one of the diagrams how the system will look like when you install it. So just a quick note on when you're designing your PCS system. So when you're designing your PCS system, look at the amount of inductive loads on site. So if you have motors that are 10 kilowatt and above, it's best you put them on drives. And then your inductive loads should not exceed 50% of your PCS when they are on drives. And then on HPS, any motor above 10 kilowatt should be on drive, HPS 150. And if it's 36 kilowatt motors, should be on VSDs. So please, when you're designing your system, take note of the inductive loads. So the challenge we are having is you have inductive loads running your system. You see your total peak load is 400 kilowatt. And then you put a PCS 500. And then your system is running at 350 kilowatt. Then you start a 50 kilowatt motor. And then your startup currents will cause the system to go into an overcurrent fault, because now to start up for a direct online motor can go as far as 5 to 7 times the normal operating current. So in that event, now you have your current limit exceeded, maybe for one phase or all the phases. So your system will start tripping and then you start fighting with the clients. So it's best you check when you're doing your load analysis, you check what are the peak currents. Always take note of the peak currents, which devices are causing those currents. And then you put drives on all motors which are above 10 kilowatt. So this is how our HPS, the PCS looks like inside. So these are our capacitors, the DC bus capacitance. This is the control board, the relay, and the sampling board. And then we have the DC breakers here. And then we also have like the dry contact relay where you can start and stop your generator. That is number 10 here. And then you have your output here. And then there's, so in the event that this is the PCS 500, the isolation transformer is a standalone component. So you have to connect the isolation transformer here. So this is the diagram, simple diagram for PCS 250. I will show you how you connect your transformer. So cable requirements, PCS 500 battery, 95 square millimeter cable by 95 by 3. These are the recommended cable sizing. So you can also calculate your own, and then, but you shouldn't be lower than this. Should be in the same range with these values that are given here. So when you're designing, just refer back to these slides. So this is the home page for PCS 250. It's pretty much the same. There's no difference with PCS 500. So when you're running a PCS 500, it should write PCS 500. If you see PCS 250, contact technical support, we take you through on how to change this. You just go to your system setup, factory pages, and then you select PCS 500 or 630, or if it's 250, you select 250. But if it's first time doing it, please ask our technical support guys. We help you with this, and then from there, I think you can do it even on your own. But if it's first time, ask for help. We are always ready to help you. So if you see your system is writing Chinese here, if you go to system setup, you just click here to change your language. So these are the parameter pages on the PCs. They are the same with HPS. The only difference is on this page. So on the HPS, you have your ATS, so bypass model. So if you're running bypass, if it's PCS 500 bypass, you're running bypass 500, it should show bypass 500 here. Or if you are using bypass 1000 on PCS 500, it should also show bypass 1000 here. Limit power exporting to grid. So if you want to export your power to grid, you can limit it here. So if you can limit to 100 kilowatt, you not exceed 100 kilowatt. You can limit power taken from your generator using this value. So if your generator is not big enough, you can limit it. Bypass station number. So if you have 3 bypass in your system, you can change the station number. So each PCS will have its station number bypass. So PCS 1, bypass station number 1, PCS 2, bypass station number 2. And then for your bypass to be able to communicate with your PCS bypass station number set, you set it on the sample calibration. You enable your bypass communication the same way you enable your BMS communication. So inside the bypass, we have grid input, generator input, and then we also have the PV input. On our settings, it's called CP. That's our PV input. So if you've I see in SA there are a lot of sites that you've got grid tie systems only. So now clients wants to put the backup system. So you can take your PCS and then put it in the same circuit with the greater inverters. You connect the output of the PV inverters to the PV input inside the bypass. And then you have to enable CP here, that you're enabling your PV input, so that the system will know that I have PV inverters connected to the system. Let me just find, okay. So in the event that you have a PBD system running, you enable your PBD. In the event that you have grid tie inverters, you enable your CP. And then if you're running with PCS 500, two of them, and you are running with bypass 1000, you have to enable bypass share enable. So you are sharing, the PCS will know that we are sharing the same bypass. And then these settings, they are just the same with your HPS. So most of the settings on the PCS, they are the same with the ones that are on HPS. So your grid and PV charge enable, you have to enable it. Anti-backflow enable, you set to 0 if you want to export, and you can set the export limit. Generator enable, if you have generator, you enable it. PV inverters, you enable your CP. These are some of the tools that we expect you to have if you're going to site for troubleshooting. So, David, things like emulator, you can write us an email, or you write Jean an email, and then you can get some of these, so that if there is a client that needs an emulator when updating firmware, you can just give them and then they return it back. If there's someone who needs it, you can get, so you can get about 2 or 3. I don't know how many we have at the moment at the office. So you get these ones. So when troubleshooting your system, you have your historical data. So history information. On the history information, that's where you see the faults. It could be a phase sequence fault, overload fault, overcurrent fault. This is where you see your fault pages. So when you're troubleshooting, the first thing that we ask is your historical information. We check, is it a software failure, parameter setting error, a hardware failure. So on this one, we help you do the troubleshooting. I'm sure we'll organize a troubleshooting session where we can do a training on troubleshooting the system. But the troubleshooting, it makes sense when you've done 2 or 3 sites. It will start making a lot of sense when we do that session after you've done maybe 2 or 3 sites. So the bypass, this is our bypass machine. This is the second diagram. So as I was saying, we have the inverter module. This is where you connect your PV inverters. The output from PCS, you connect it here, and then you have your load in the bypass breaker. You have your grid input, your generator input. And then module number 4, these are just conductors that will distinguish between generator and grid, so that if you set your system to export to grid, it will not export whilst the generator is running. So this is the inside of our the structure of our bypass. The PV input, PCS, bypass your load, grid and generator inputs. So for PCS 500 and above, that is PCS 500, 630, and PCS 1000, you will need an isolation transformer, which is an independent component from the PCS. The PCS 250 is the transformer inside because it's small. But for 500 now, the transformer is very big. It couldn't be fit in the one device. So when you're connecting your transformer, please, when you're connecting your transformer, follow the SLD diagrams that I'm going to share with you. This is how you connect your transformer. So the secondary side of the transformer is connected to the conductor at the back of the PCS. That is 500 in this case. At the back of the PCS, you connect the conductor to the secondary side of the transformer, and then the primary side, you connect it to the inductance of the PCS. And then the load and grid is just the same. So you find this at the front of your bypass. So always take note of these connections, because if you make a wrong connection, yeah, I've seen problems where now you have to buy new cables, and then these cables are very expensive because it's 95, 150 square millimeter cable is very expensive. So before you cut your cables, before you do anything, please seek clarity if you are not sure, because this mistake is very costly. So just seek clarity if you are doing this connection. We help you with this connection. We do online support, which is free of charge. So this is our bypass communication port, where you connect from CAN B, you connect it to CAN A. It's stay in the SLD. You can follow the SLD. If you are not sure, just send any questions to the IBC Solar team. We can respond them via email, or we can have a session, a call, if you are not sure. And then inside the PCs, that's our dry contact for generator start stop. So 412 normally closed, normally open. So these ones will depend on your generator controller, how you connect it. But this is for generator start stop. So we have two sides where you can connect it, 412, 812, or you can connect on the other side. That's 1519. Where to find the dry contact relay? Just below these breakers on the side with the SPDs. So it's for diesel generator start stop settings. It's the same with the HPS, where it's your lower limit or down limit start and then stop. This only work when you enable your generator function. So float current limit setting, discharge cutoff voltage. So discharge cutoff voltage, you don't have any output. Your generator, so if you're running if you don't have BMS, your generator will be start and stopped with the voltages. So if you're not running a battery with BMS, then you can contact us and then we help you on how to to set your generator start stop using the voltages. And then the last setting here says CP nominal power. So if you have a grid tie system already existing, say 200 kilowatt, 500 kilowatt, you just put it here. The nominal power of your system is 500 kilowatt here. And then if you have grid tie inverters, I advise you get a controller that will control your PV inverters for the charging and discharging. Yes, our PCS can do frequency shifting, HPS cannot. So if you've grid tie system on an HPS system, you connect it on the load side. On the PCS system, you connect it on the grid input breaker, and then on the PV input breaker, and then you also need a controller to control your PV inverters. It can also monitor. We have seen, as I mentioned before, there is Elam, Data Guru, Solar MD. They have their own, and Freedom One also had their own. I'm not quite sure if IBC have a controller, a
Yes, we
third
do.
party.
Yeah.
You do. Okay.
Yes, we have our
Yes.
blue lock. Yeah.
Blue
Meter
Lock.
control.
Okay.
Yeah.
Okay. So those are the controllers that are there in the market. So I would advise you, if you're getting your equipment from IBC, it's best you take the controller from there. It's easier when we're troubleshooting. So they will know this is an Atess equipment. Atess, there's an issue with this. The controller, it's easy for us engineers to also get in touch with the support team from the IBC and try to solve your issues. Unlike if you get different equipments from different people, it will be difficult for us to also, come together, come on site, the whole team. So if it's just 2 or 3 companies, it's easier to arrange. So yeah, I would advise to use an in-house controller in the event that you have PV inverters installed. Most of the PV inverters, they are compatible. We've done sites with SMA, Solar Edge, Huawei, Solis. Yeah, those are
Have
some of the inverters that we've done, and I can't remember some of the names, but most of the inverters they're compatible.
Have you guys worked with Goodby by any chance?
Yes, we've done, I think, about 2. I was in the engineer in charge of that site. I think it was Jean. So if you have any Goodby site, you can contact Jean or myself. We can talk in-house and then help you with it. So the only thing that needs to be done is just to get information from your inverter, and then your controller gets your information from RS485 interface, and then you control using that. It's not a difficult thing. So long your controller that you're using is good and you have good support. The only thing that you should know is you have good support when you are buying your controller. So that's the most important thing. And then I think I'm done with this. I don't know if there are any questions. Let me check. Okay. So the first question I'm seeing here is, please confirm if bypass can also be paralleled, or what is the solution if 2 megawatt of PCS or 4 megawatt of PCS, but maximum bypass size is 1 megawatt. Yes, the bypass can be paralleled. So if you have 4 megawatt system PCS, you also need 4 bypasses. You also need 4 isolation transformers for each and every PCS. And then in the event you have 2 PCS 500, you can use 1 megawatt bypass. But you can also parallel them. You can use 5 500 bypass. It's okay. Yes, it can be done. And then the other question, you can parallel them. Yes. So 2 megawatt, you can use for PCS 500, for bypass 500. Yes. 2 PS 1000. On that one, no. At the moment, no. You can only use 2 PCS 500 with 1000, but you can't parallel the 1000. At the moment, no. It's being tested, but if everything is tested and done, then we can advise you that you can do this. But at the moment, no. Is it compatible with day? Sorry, on this, you're saying the day the grid tie inverters or the hybrid inverters. I'm not quite sure what you asking here. I don't know, David. Can you find out? Hello.
Mm, I think that should be. I think that should be it.
Okay. Any more
Mm.
questions? If you have other questions, please. Okay. Whether the system is compatible with grid tie inverters. Yes, most of the grid tie inverters, they are compatible. So
Basically, just needs a proper power plant controller by the
yes,
looks of it. Yeah.
yeah, what you just need is a controller. So if you check with IBC, the controller, can they control this inverter? If yes, then you should be fine.
Yeah, so so what we do on our side with Daya, we don't have it on our power plant controller at the moment. But
Okay.
however, for each and every site, our R&D team then works on implementing the grid tie inverters. And then as long as we have the Modbus registers, we can then get that started. So it's something that maybe we can have a discussion on, and then we can assist you.
Okay, yeah. I'm sure you also have our Modbus registered, right?
Yes, we do. Yeah.
Yes,
So
yeah.
ours
So,
is Atess HPS is compatible, and then the PCS is currently on beta version, but we should very resolve it soon.
okay,
We
that's
just like
fine.
having to test it on site, and then before we can move it out of beta version.
Okay,
Yeah.
that's fine. I don't know if there are any other questions. I see we are left with 13 minutes to go.
Okay. Seems like we do not have any questions. Um, if you do, maybe after the webinar, do have any questions, please feel free to then contact IBC. I will then drop our technical department email, and one of us will then come back to you. And then I also did just drop my email so that we can just discuss on the power plant controller if you want to integrate it with Daya.
Okay. So, guys, if you are doing a commissioning, it's best, I advise clients, it's best we start in the morning. If we have any issues, we have enough time to solve all the issues. So it's best we start in the morning, and also it's also advisable to get in touch with one of us on time, or a day before, 2 days before. You can book one of our engineers 2 days before, 3 days before. Okay, guys, I'm going to do a commissioning, a 500 kilowatt HPS 150 on this day, and then they clear their desk so that they focus on you. And then when it comes to faults, you just contact us. We are going to set up a ticketing system. We're still testing it, but it should be up and running soon. So if you're doing a commissioning, please get in touch with us. It's best you do it in the morning so that we have enough time. I've had clients calling me 5 p.m. Can we start the commissioning? It might not be good. Now we don't even have the to test our PV because it's now at night. So it's best we do it starting in the morning. But if there are any issues that we can't start in the morning, even during the day, we can start. But end of the day, we might have problems when testing. So I don't know if there's anything else or we can call it a day. So on which email should I send the documents?
Tatiana, you can send it directly to me. You can respond to that reminder email I sent this morning. It will be all good. Then I'll share it with everyone.
Okay, that's fine.
Okay. The recording and the presentation will be on the link that I've sent. I'll send it now again in the chat section for all participants. So just check that link.
Okay, that's fine. So if clients start installing and everything, please, you can also organize a troubleshooting session. It will definitely help Atess, you and our clients, because there are some basic troubleshooting things that they can just do on their own, but they can only do it after we show them, we train them. So it will be of benefit to everyone. So yeah,
I will
that's all
set up a
Definitely.
training for that one.
yeah.
Okay.
Okay, ladies and gentlemen, I think that we can then call it the end of our session today. And until we meet next time on our next training, everybody, you can just enjoy the rest of your day. Thank you for joining
Okay.
us once again, and hope you have a good day ahead.